Howdy folks, Donnie here with you once again. And what I'd like to do is to begin a series of videos showing how to use the command line utilities to manage Linux users. So you're saying, okay, we have our nice desktop interfaces, we have a nice GUI program that we can use to create users and manage our users. Why do we need to learn how to do it from the command line? Well, it's just the simple fact that when you go into wanting to be a Linux systems administrator, you're not always going to have that graphical interface available to you. A lot of times you're going to go in, actually I'd say most of the time, you're going to go into a shop that has Linux servers and you're going to see nothing but text mode interfaces. So you need to know these utilities. And the second reason you need to know how to use these utilities is because you may have to, at some point, create shell scripts that will automate the creation of these user accounts or the management of these user accounts. You know, for example, if you have a whole bunch of users that you need to create accounts for all at the same time, by using these command line utilities, you can put a for loop in a bash shell script and just have that shell script read the names out of a list in a text file and just automatically create the user accounts that way. And there are other scenarios as well where you would want to be able to create the user accounts from within a shell script. So those are the types of things that you cannot do with your graphical user interface utilities. You have to use them with the command line utilities. Now, you can see here the plan is to create 4 different videos on the topic of user management. The reason for that is because we have a couple of different ways to create our Linux user accounts. We have the Red Hat way, and then we have the way for pretty much everybody else, the non-Red Hat way. So rather than try to put all of that in the same video, we're just going to break them up, okay? But we also have a couple things there which are common to all Linux distros. Our configuration files are going to be pretty much the same with some differences. We'll point them out in videos 2 and 3. And video 4, our user management, for like user modification, adding people to groups, deleting accounts, things like that. That's pretty much common to all Linux distros as well. So we will do these 4 videos, and we're going to start right now with video number 1. We're going to take a look at some of the configuration files that are common to all Linux distros. So let's go over to our virtual machine and we'll take a look. So here we are on our CentOS virtual machine, which represents the Red Hat way of doing business. But these first few files that I'm going to show you are identical across all Linux distros. So there'll be no difference there. That's what I'm going to show you now is going to apply to all Linux distros. And then I'll show you a couple of configuration files which are going to be a little bit different across the different distros, but they're still there on all of our Linux distros. And, in the appropriate videos, I'll show you what the differences are. But anyway, let's go into the etc directory. And we're first going to look at the passwd file. And we can just go ahead. We'll open up in our Vim text editor for the sake of getting that nice color coding, which makes things a little bit easier to see. And so here in the passwd file, which is short for password, but ironically, there are no passwords here, and I'll show you why here in just a little bit. But what we do have in this passwd file is a list of the different user accounts on the system. We have 3 different types of user accounts. We have the root user account, which is the super user. Then we have a whole bunch of different system accounts. And I'll have to page on down here to show you all of them. And then finally, we have our normal unprivileged human user accounts. And you can tell that I am the person who installed this operating system because I am the first human user account. Yay! So anyway, let's go back up here and we'll take a look at these different fields and see what they mean. Well, first off, and first let me cursor down here to get that cursor off my root field. There we go. So anyway, what we got here first is we have these 7 different fields in each line. And each of these fields is separated by a colon. The first field is the name of the user account, in this case, the root user. The second field is the password field. Ironically, though, even though this is a password file and this is a password field, you never want to see a password there on modern Linux systems. I will explain the reason for that in just a few moments. The next field is the user ID number field. The user ID number of the root user is 0. Now, one little tip here, one little security tip, is that when you open up this file on a Linux system, if you ever see more than one user account with a user ID of 0, you know that you have a problem. Somebody came in and did something nasty that they weren't supposed to do, because that user ID number of 0 is what gives the user account the whole big, all-powerful root user privileges. Okay? So if somebody were to create a user account with some other name and give it a user ID number of 0, that account would have full root privileges. So you never want to see more than one account on a Linux system with a user ID of 0. Now, on a FreeBSD system, that's a different story. A FreeBSD system, you will see 2 user accounts with a user ID of 0 because they have one user account, for one purpose and one for another purpose, okay? But anyway, on a Linux system, never do you want to see more than one user account with a user ID of 0. The next field is the group ID number. And so the group ID number for the root group, for the root user group, is also 0. And down here you see that some of these system accounts have a group ID of 0, and that's fine, okay? Just so long as you don't see more than one user ID of 0. The next field is a comment field, and you can put pretty much whatever you want to in there. You can put in the user's full name, you can put in contact information, pretty much whatever you want. The next field represents the home directory for this particular user. So in this case, we see that the root user has a home directory of /root. Okay? So in other words, when the root user logs in to the operating system, he is automatically going to be logged into this directory as his home directory. And this is kind of like on a Windows system when you log in and you're automatically logged into the My Documents folder or Documents folder, whatever they call it on the particular version of Windows that you're using. And then finally we have the default shell. So in this case we see that the root user will be using the bash shell as his default shell. Now down here we start with our system accounts. And system accounts are used for pretty much the same purpose that system accounts are used for Windows machines. It's just so that different processes can be owned by unprivileged accounts so that it will make it harder then for bad guys to come in and take over these different daemons and services for their own nefarious purposes. Okay? But in this case also, for our service accounts, most of them are using a default shell of no login. So this is another safety feature which prevents users from being able to hijack these accounts and log into the system. And then we can go on down, and here, my user account, this Donnie character. Yeah, that's me. Yay. And you can see there, that is my comment field. And my home directory there is in /home Donnie, and I am using the bash shell by default. Okay? Now, we said a moment ago that even though this is supposedly the password file, there's no password in there. And the reason for that is because this file has to be world readable so that when somebody logs into the system, regardless of who that person is, he or she needs to be able to read that file in order to obtain his or her information that's required to log that person on, right? So years ago, back in the dark days of Unix, early man did put a password in that password file. But since it's world readable, it was kind of a security problem. So somebody along the line then came up with the idea of the shadow system. So who knows what evil lurks in the hearts of men? The shadow knows. Yeah. But anyway, you see the shadow file there also in the etc directory. And it looks rather unusual here in that nobody has any permissions at all to access that file. At least that's the way it is on Red Hat systems. If you go over to a Debian or an Ubuntu system, you'll see that it has read permissions for the user, for the root user, but no other permissions. But either way, it's still the same. And with root privileges on a Red Hat system, even though there are no privileges here at all listed, we can still get in there and see what it looks like. We can open it up in Vim, except it's going to open up in read-only mode. So you see down here, read-only. Yeah. But anyway, this shadow file has the same list of users in it that the Passwd file has, and all in the same order. And this is where we have the passwords. Well, not really the passwords, but we have a hashed representation of the passwords. And so here, for example, we have up at the top the root user. And then we have this field. The second field is the password field. So that is the hashed password. The $6 means that we are using the SHA-512 hashing algorithm to create this hash. If you see a $1, as you would see on an old CentOS 5 or Red Hat 5 system, then that would represent the old MD5 algorithm, which is now considered too weak to use. But for CentOS 6 and CentOS 7, we're using SHA-512, which is a lot stronger. OpenSUSE systems use the bcrypt algorithm, and I forget what the number is there, but it doesn't matter. It's still all the same principle, okay? So anyway, that's our password field. And along with our hashing algorithm, we're also using a salt value. So the salt value, what that does for us is it just adds some sort of a random number in with the hashing algorithm when we create these password hashes, so that if we have more than one user account that uses the same password, the hashes will be different. So that way, even if somebody were to come in and be able to access the shadow file somehow, they would not be able to tell that different accounts might have the same password. So for example, just look at here, take note of what the hash is there, and then we'll go on down and we'll see what the hash is there. And I know you didn't memorize the hash, but you can probably see that it is radically different. I won't tell you what the passwords are, but I will tell you that they are the same for both the root account and for my account. And yet the hashes are radically different. That's what the salt value does for us. And then, if we go back up, we're going to see that the rest of these fields are going to pertain to password aging information. And you don't need to know what these different individual fields mean, because you're not going to read them or work with them directly anyway. Just know that when you use their different utilities to set either password expiration or things like that, any type of expiration data for the password, these are the fields that will get affected. These are the fields which will get changed. So you've got that. And then also in the password field for the system accounts, you see that some of them have an asterisk and some of them have a pair of exclamation points. But either way, it does the same thing for us. It just means that whether you have an asterisk or a pair of exclamation points, either one, it just means that those user accounts cannot be used to log into the system. So that's the second safety measure that we have with our system accounts. And then, of course, down here, we'll go to the bottom and we see my account. And, well, it's pretty much the same as the root user account, okay? So that's it for the shadow file. So the next thing we're going to look at, also in the etc directory, is the group file. And this is just going to contain a list of groups that we have on the system, the list of user groups and their membership. And again, we start off with the root user up here. And again, the password field. And again, you will never see a password there. And the group ID number. And then down here, since this is a Red Hat type system, we see the wheel group. And we see that I am a member of the wheel group, which means that I have full sudo privileges. And on a Debian or Ubuntu system, you would see your name in the sudo group instead of the wheel group. That's one of the differences in the different operating systems, the way they do things. And then you have all these different system groups. And then you come down here and you'll see my group. And this is also something else that's done differently across the different Linux distros. On your Red Hat type distros, and Ubuntu and Debian are doing it now. The user account, each normal unprivileged user account, has its own private group. On other Linux distros, Slackware is like this. I think Arch is like this as well. Those other groups, instead of having each user with its own private user group, the users will just be thrown into the users group, which is something I don't really care for. I like this way of doing business a lot better, where each user has his or her own private group. Now, with these private groups, for the individual normal users, you're not going to add any more members to those groups, okay? But for these other groups, like the wheel group, for example, you can add members there. Like, there's me. And if I wanted to, I could add other users to that wheel group so that they can have full sudo privileges as well. And we can also create our own special purpose groups, which we'll talk about later as well. And special purpose group, we could say like for maybe the accounting group, and just add members of the accounting department to the group. Or the marketing group, add members of the marketing department to the group, things like that. And then we could set up shared directories for each group and give that group the permission to cd into that directory, to be able to access that particular directory. But anyway, we'll talk about that just a little bit later. The next one is going to be the gshadow group. And again, you see there that it has no access permissions on it at all. The gshadow group is to groups, or excuse me, the gshadow file is to groups what the shadow file is to users. So the theory here is when you create groups, you can assign a password to the group, and then instead of adding members to a group to allow them to access the resources, you can make it so that the different users will have to enter a password in order to access some resource that belongs to that group. So for example, if you set up a shared directory for a group, and instead of adding members to that group, let's say it's for the accounting group, right? So instead of adding members to the accounting group, then you can just assign a password to that group in this file, and then give that password to the users that you want to be able to share or to access that accounting group directory, right? And then when they try to CD into that directory, they'll have to enter a password. However, that is a really, really bad way of doing business, because if you have somebody that has had full access to that group's resources, and then for some reason you want to remove that person's access, the only way you can do it is to change the password for that group, and then give everybody that you still want to be able to access that group the new password. So, bad way of doing business. You don't want to do it. So, for that reason, we're not going to talk anymore about this gshadow file. So, we're just not going to use it. Okay? Also, in the etc directory, we have what we call the login.defs file. Not sure why they call it that. It's kind of a silly name for it. But we can go in here and see what we got. And what it is really is just a file where we can set certain defaults for when we create our user accounts. And this is going to differ a little bit from one distro to the next, but there are some things that will be kind of the same. Like, for example, it's here in this Red Hat style one, we can see there that it is going to determine where we create a mail spool when we create our user accounts. And we also have our default password aging information here. We can set the maximum number of days that a password will be valid. And when you see it set to a string of 9s like that, that just means that the password will never expire. But we can change that if we wanted to. And so we could, for example, come down here. And we could change that to 90. So that way, when we create a user account, it will automatically make it so that the user's password will expire after 90 days. And for password min days, it's set to 0. That just means that when a user changes his or her own password, then they'll have to wait that number of days before being able to change it again. But when it's set to 0, they don't have to wait at all. They can change it at any time. But let's say you want a user to have to wait 5 days before changing again. You can do it like that. This password min length is completely ignored in this file because we have another mechanism called PAM, which controls that. And it says there password minimum length is 5, but in reality, it's not going to work unless you have a password with a minimum length of 8 characters. Okay, and that's because of PAM. So I don't know exactly why that line is still there, but just know that that line is ignored. You can change this line here to anything that you want to, and it's not going to make a bit of difference because of that other mechanism that we have. Okay, and we'll talk more about setting password length criteria in a future video at some point. And then we have the password warning age, and this just means that in this case it's set to 7, so it just means that when a person's password is about to expire, he or she will get 7 days warning about having to change it. Okay, But again, you can change that to whatever you want. So let's say that we only want to give them 5 days. We can do that, right? And then, of course, we can save that file if we want to. We're not going to save it here in this case. We're going to leave it the same. But anyway, that's pretty much it. And then down here, we have our minimum and maximum values for user ID numbers. And if you remember, you saw in the Passwd file that my user ID number for the account that got created for me when I installed the operating system was number 1000. So that indicates that I am the first person, to ever have a user account on here. And the maximum user ID number is 60,000. So that leaves what, like 59,000 users that can be created on this machine. And this is actually going to be different here across other operating systems as well. Some distros might start that minimum ID number at 500, like CentOS 5 used to start it at 500. Then going into CentOS 6, they decided to up it to 1,000. I'm not sure why. And then we have system accounts. When you create system accounts, the user ID number will start at 200, and the maximum will be 299. And then we'll have the same thing here for the group ID numbers for both the normal user accounts and the system accounts. And then down here, do we want to automatically create a home directory when you create a user account? Yes, we do. And this is set to yes automatically on the Red Hat style systems. On your other systems, you don't have that. It's not set to yes by default. Okay. And then down here we have the UMask of 077. And this just governs what the permissions values will be on the user home directories that get created. So the 077 UMask means that all permissions will be taken away from both the group and others, and only the user of that group, the person who actually owns, the person who actually owns that directory will be able to access that directory. Okay? And we can see that by coming over here, and we just open up another window here. And we can go into the home directory, or the /home directory as I call it, and you can see this is the result. That 077 UMask makes it so that my home directory can only be accessed by me. But once we get over into the other videos for creating the non-Red Hat accounts, then we're going to see that that's different on other operating systems. The other operating systems allow other users to get into people's home directories. So that's something that you would need to change on those other operating systems in order to have proper security. And then down here we have our encryption method. And this is kind of a misnomer. They say that this is encrypting a password, but it's not really encrypting a password. It's hashing, which is a different thing. When you encrypt something, it implies that you have some sort of a program that you can pull up and enter a password in order to get the original file back or the original value back. But with hashing, you don't have that. Once something is hashed, it's hashed. You're not going to get the original value back. All right. So we are using SHA-512 here on our Red Hat style systems. The final thing I want to look at is going to be in the etc default directory. And that's this user add file in the etc default directory. And this is another place where we have default settings for our user accounts that when they get created. And so here we're going to create our home directories for our users within the /home directory. Inactive equals -1. When it's set to -1 like that, that means that when a user's password expires, he can go as long as he wants to before changing it, and it's not going to hurt anything. But if you set that to some positive number, Like, for example, you set that to a, let's say we set it to 2. That will mean that once a password expires for a user, then that user will have 2 days to change that password, or else his account will be locked out and he'll have to call an administrator then to unlock it. Okay? But we're not going to change that. We're just going to leave that as is right now. We can also set an expiration date for user accounts, and you can edit all this stuff here by hand in the Vim text editor if you want to. But a little bit later on, I will show you how to use the user add utility in order to edit this from the command line, which makes it a little bit easier, a little bit less prone to error. But anyway, the expiration date, if we set an expiration date in there, that'll make it so any user accounts that we create will expire on that date automatically. Okay? Now, understand, account expiration dates are different from password expiration dates. 2 different things. That's something that we'll look at a little bit later. We can also have the person's default shell, and 99.9% of the time, you're going to want to just leave that set to bin bash, so that the person will be using the bash shell. The shell is a directory that has certain files in it and directories in it that will get transferred over into a user's home directory as the account gets created. And so we can look at that. It's in the Etsy directory. Okay? And we can go into there and we can do ls-l, and oh, nothing there, right? Well, actually there is. We just have to do it ls-la, because all of these files and directories in here are hidden ones. Okay? These are going to be files and directories that contain configuration information for the person's bash shell environment, and also for the person's Mozilla environment, which is going to include Firefox and Thunderbird. So anyway, that's it there for the files that pertain to the user account management on a Linux system. In the next video, we're going to look at creating users the Red Hat way. And until then, I think it's all for now. If you like the videos, be sure to like and subscribe, and we will see you in the next video.